All right, welcome back to my stream and happy Monday. This is this is the week that we're going to switch back to crafting interpreters. Let's see, there we go. We should be up and running now. Yep, and that's right. Last week we finished. We left off with 14 errors in our code because we were switching the game log. And this was for the roguelike that we were working on. So all the logging changes we were making. Yeah. And so there's still 14 issues that need to be resolved there. And we're just going to say, see you next week to those. We were on Locks AST here. Yeah, so we're clean. And we had gotten for this, we had gotten as far as 11.4, which is the resolver. So we'd started doing the resolver stuff, and then we stopped just before 11.5, which is resolution errors. So let's take a look at our log here. Yeah, section 11.4, complete resolving variables. And we had to do some sort of a refactor in order to get that to work. I'm not all that thrilled with that, but it does the job. It means that we're passing in, if we look at our resolver code, for example, every statement has, or every visit function has an RC of the statement, and then a broken out or a deconstructed version of it. That's from the inside. If we look at those real quick, just to see. So our statement is an enum type, which is a block statement or a break statement or expression statement and so on. And each one of them has a reference counted variable or a reference counted struct inside. And then when we call the visit, where's the visit? Yeah, so we call accept. Accept calls the visitor function, which calls it with the RC wrap. I call it wrapper, and then the destructured version of that, so we can get inside the RC and get that value. So it's a little awkward. It would be nice to think of a way to clean that up. And maybe the better I get at Rust, the more I can, the better idea I can come up with to handle this. But this is working, so I'm not going to dig into it right now, and we're going to go switch over to this here, those resolution errors. So let's take a look at that. Take a look at that right now. Yeah, and we were clean, so git status good. So resolution error, section 11.5. Since we are doing a semantic analysis pass, we have an opportunity to make Lox's semantics more precise and to help users catch bugs early before running their code. Take a look at this bad boy. Function bad, var a equals first, var a equals second. We do allow declaring multiple variables with the same name in global scope, but doing so in local scope is probably a mistake. Can we do that right now? If I did that? And will it just overwrite the second one? Oops, bad, semicolon. It doesn't complain, but who knows what came out. Or A should have been, I think this will just be a printing second, right? Yeah. We do allow declaring multiple variables within the same global scope, but doing so in local scope is probably a mistake. If they knew the variable already existed, they would have assigned to it instead of using var. And if they didn't know it existed, they probably didn't intend to overwrite the previous one. We can detect this mistake statically while resolving. All right. So in the resolver, in declare, so right now we have scopes peak. So this is my version of scopes peak, right? So scopes borrow last is scopes peak. And this is saying if it contains the key already, then we can say already a variable with this name in this scope. So how do we translate that into Rust here? What we can do is actually do this in a slightly different way, right? We can say if let some scope equals self scopes borrow last, right? And that'll return none if there isn't one, and that does the peak for us. And it'll return some scope if it's there. So then we have the scope. I don't know why I didn't do that before. That would have made more sense. It'd be rustier anyway. So we say if scope contains key, then we're going to return a locks error. Oh, right. So this is the situation where we want to report the error and then record the fact that an error occurred, but not throw anything, right? Not abort. Okay, so how do we do that? Do we have a has error? We don't. Let's add that. And then we'll add an error function. Had error is on a ref cell of a bool, right? And that way we don't need a mutable reference to it. And then down here we can just say error, and then we'll take a token and a string like that. And then we can just record the fact that there's an error. Self had error replace with true. Oh, I forgot to pop up my my chat, and I missed Drew saying hi. Hi, Drew. Okay, replace with true, and then we'll just record the error. Locks error, locks result. Run time error with name and message. That way it'll get out to the user. Okay. And then where were we? We were up in declare. So if it contains this, then what do we do? We just call self error with name and ready up scope, and then we just carry on. Scope put insert name as string false, and that cleans all that up. Oh, scope borrow mute, right? Because we have to borrow the internal ref cell as well. Yep. And then we can clean up define. Let's clean up define at the same time. Scope. And then just insert like that. What doesn't it like? Oh, I don't have the had error initializer. And this is token. Like that. Okay. Is that it? No, we still have 3 errors. What doesn't this like? Oh. Borrow. Name is string. And this is a function. And this is last. Wow. Okay, so that works. Or at least that compiles. I do want to go back to my main, our main, and just check on the resolver here. So we do the resolver resolve, and then we say if not, if resolver, we'll use the same pattern we have here. Success, then we do the interpret, which means we have to write a success function, which is pretty straightforward. We're Just say, let's put it up with the other pubs. Pub fun success, self, returns a bool, and then we just return not self had error borrow. I might have to dereference that. Let's see. Yeah, okay. All right, let's see if this works. Cargo run. And let's put this function in here, this bad function. And it says line 1, at A, already a variable with this name in the scope. And if I look at our environment, there is no bad function called bad in here. So that seems to work. If I say fun good, and just print that and call good. So now, yeah, now we have a function called good in there. Good. Okay. All right, so that works. That was section 11.5. Point 0, I guess. And this is just redeclaration handle, I guess, handle redeclaration errors. Okay, and then we have invalid return errors. Here's another nasty little script to return at top level. This executes a return statement, but it's not even inside a function at all. It's top level code. I don't know what the user thinks is going to happen, but I don't think we want locks to allow this. Say cargo run, return 5. Well, I mean, it didn't blow up. We can extend the resolver to detect this statically, much like we track scopes as we walk the tree. We can track whether or not the code we are currently visiting is inside a function declaration. All right, so we're going to have a current function value in our resolver, and then have a, instead of a bare boolean, we use this funny enum, none or function. Seems kind of dumb now, but we'll add a couple more cases to it later. All right. So we're going to create a funny little enum. Enum function type. And it's either going to be none or function. Put the comma there. And then we're going to add function type here. Current function. All right, and then we have to initialize it. Where's our initializer? Right here. Oh, it's function type none, like that. Okay. This will seem kind of dumb. Okay, when we resolve the function declaration, we pass that in. So in visit function statement. So we declare, define, and resolve function, and we're going to pass in function type function. Okay, and then in resolve function, we're going to save it. Okay. Where is resolve function? There it is, right at the bottom. Okay. So we do, oh, even before we do begin scope, we're going to do this. We're going to add our function type here. I don't want to call it type, F type. I can't call it type because that's a reserved word in Rust. And this is a function type. And then before we do anything else, we're going to set the enclosing function to the current function and the current function to type. So enclosing function is equal to self current function replace with F type. And then we have begin scope. We stash the previous value in the field in a local variable. Remember, lock says local functions, so you can nest function declarations arbitrarily deeply. We need to track not just what that were in a function, but how many were in. We could use an explicit stack of function type values for that, but instead we'll piggyback on the JVM. We store the previous value in a local on the Java stack. When we're done resolving the function body, we restore that field to that value. So right after in scope, we just say self current function replace in closing function. And we're done. Now that we can always tell whether or not we're inside a function declaration, we check that when resolving a return statement. So in visit return, if self current function borrow is equal to function type none. And again, we're going to say self error statement keyword can't return from top level code. Okay. Does this check? Does not. Oh, I have to make this derive partially q. Still not good enough. What are the mismatch types? I'm thinking I put the ampersand there because I thought I had to we got a ref back, but maybe we do this. Yeah, okay, so that fixes it. And then statement keyword expected token found token. Okay. Expected token ref. And I mistyped this one. Okay. So cargo run. Return 43. There you go. Can't return from top level code. Okay, that's working. Neat, right? That's what it says right there. There's one more piece. Back in the main locks class that stitches everything together, we are careful not to run the interpreter if any parse errors are encountered. That check runs before the resolver, so we don't try to resolve syntactically invalid code. But we also need to skip the interpreter if there are resolution errors, so we add another check. Okay, I did that already, actually. You can imagine doing lots of other analysis here. For example, if we added break statements, we would probably want to ensure that they are only used inside loops. Oops, I think I added a break statement. Yes, I did. And right now, break is handled anywhere. So if we're going to do this, we need to say that, right? Because if I say cargo run and then just a break. Oh, break outside of while forward. So we already have that. That's in our interpreter. We already detect. But they're saying that we can actually detect it at resolution. So even before we run any code. And the way I did this was just with a counter here to make sure that we were inside at least one. Right? Every time we hit a while statement, we'd increment. If we handle it in the resolver, though, that would make the interpreter go faster because it wouldn't have to do this check every single time. Anyway, we can actually do it using the same method or the same manner. I shouldn't use method, right? The same manner that we use this function type. We can say in while and just make that a ref cell of bool. And then in while, we can, before we do anything, we just say let previous nesting is equal to self in while replaced with true, and then say self in while replaced with previous nesting, and it gets initialized here to false. I want to see if this works. In while ref cell new false. Oops. Right, and then and then in the break statement we look. We can say if not self in while borrow, and then we'll just report an error, self error. I guess we can grab the statement. What's in the statement? It does have a token. Okay. Statement token resolver. I'll put this here just to see the text. Break statement outside statement outside of a while or for loop. Right? And we'll just leave it like that, and then okay. Okay. No, it doesn't like that. Oh, ampersand. Okay, so let's see now if the resolver actually says it. Cargo run. Break. Yeah, so now the resolver sees it right away. Oh, that's interesting. I'm not, this token I'm saving is the semicolon, not the keyword break. Okay, that's fine. I wonder if that's something we can change in the parser. And instead of saving the token here, oh no, this says token self peak view, which should be the break statement. Oh no, this should be previous. That's right, this should be previous. Self previous dupe. Because the current one is a semicolon. And that way it'll be the break statement. That's the token here. All right. Let's see. Yeah, now it says line at break statement outside. Okay, good. And then I want to take out from the code here this nesting business. Visit break. So self nest borrow. So let's look for all references to nest. Like that. So get rid of that one. Get rid of that. Get rid of that. We don't need to initialize it. Interpret. Oh, okay. All right. Oh, I should have done a check here. Yeah, I have two warnings now. What are the warnings? Oh, the break statement doesn't need the statement anymore. Okay, 43. That makes sense. That should clean all of that up, and then cargo run. And I can still break here and see the error. Okay, so we clean that up. Get status. What did we also, did I forget to check it in the, or commit the return statement stuff? I forget now. Yeah, okay. So now we're gonna say return statement. Well, I missed it. Where is this? As interpreter, that's all the changes we made for that. Here's the resolver. Yeah, here's current function. Okay. And I want to get rid of the word resolver on that. to make all the error message consistent with the other ones in terms of typology. Okay. Git status, git add source, git commit, section 11.5.1, right? I think. Yep. Handle bear returns and break statements. Nice. All right. I think we're ready for chapter 12. Let's take a look at what the challenges are first. We could go farther and report warnings for code that isn't necessarily wrong but probably isn't useful. For example, many IDEs will warn you if you have unreachable code after a return statement or a local variable whose value is never read. All of that would be pretty easy to add to our static visiting pass or as separate passes. How would we... How would you check to see if you are looking at code after a return statement? It would have to be in the same block, right? Because you can have a return statement, but still have code after it that's valid, right? If I, for example, if I had like if something, you know, line 1, line 2, return, and then line 3. This line is perfectly valid, even though it's after a return statement. So you'd have to keep track of whether you're in what block you're in, and say, was there a return statement in this block that we're in already, before checking for that. A local variable whose value is never read. How would we check for that? You would have to, when we resolve the variable, right? Because whenever we resolve a statement, right, binary expr or whatever, we resolve the expr, we go through and we actually have to break it down into its components. And there has to be, at some point, a variable expr where we visit the actual variable, right? And if we never visit the variable, but we have defined it, then it's never read anywhere. So how hard would that be to add? We would probably have to extend this. Right now, this is the scopes just has a hash map of the variable name to the Boolean. We declare it by setting that Boolean to false, which puts it in the hash map but has the false on define, and then we define it with setting that to true. We would have to say read it. It's been read by this somewhere. I'm not sure I know how to do that part. At least not off the cuff. So I'm not going to do it now. For now, we'll stick with that limited amount of analysis. The important part is that we fix that one weird, annoying edge case bug, though it might be surprising it took this much work to do it. And that annoying edge case bug was all the way at the top, and they talked about how if you don't keep track of how far back you're going at resolution time, you're going to lose track of what variable you're trying to read based on if you're in a closure. And that was something we talked about 2 weeks ago, so I barely remember that, but it's something that I kind of vaguely remember that we were handling with the resolver. Challenges. Why is it safe to eagerly define the variable bound to a function's name when the other variables must wait until after they are initialized before they can be used? Why is it safe to eagerly define a variable bound to a function's name? So where do we have? We have in function visit function statement, we have declared followed by define. Other variables must wait until they're used, we must have a visit. Here's a visit var statement. We declare, then we do the initializer part, and then we define. And I think the reason we did that was to avoid the use before. Like if you say var a equals a, right? And we handle that case now, right? Var a equals a. Oh, undefined variable a. Var a equals 4. Var a equals a. Can't read a local variable in its own initializer. That's the error that we're handling. But why is it safe to do it for functions? Because you never read a function, maybe? I don't know. That's a good question. I don't know. I guess I don't know what they're getting at. When you define a function, you're just saying, fun foo. And so you're defining it here. And you can just call it like that. And that'll just cause an infinite stack explosion. I think Rust will blow up once the stack gets too deep. Yeah. That died pretty quickly. But you want to be able to use foo inside foo. So maybe why, but that doesn't say why it's safe to do it. I don't think there's, maybe it's because there's no way to break it like we can with this. How do other languages, handle local variables that refer to the same name in their initializer, like var equals out or var equals a? Is it runtime error, compiler error allowed? Do they treat global variables? Do you agree with their choices? Justify your answer. How does Rust do it? Let a equals outer, sure. Let a equals a, but let a. No errors. And printed outer. Justify my answer. I can't justify my answer. I can tell you how Rust handles it. Rust just lets it happen, takes this A and puts it in there. I don't know what issues might arise from that. Extend the resolver to report an error if a local variable is never used. Oh, okay, so that's what they were talking about back here. A local value is never read. I'm tempted to try it. How would you, so at the end of the resolve pass, right? Oh, what state are we in here? Oh, okay, here, visit variable expr. We want to mark we would want to mark the variable as having been read. I guess that's in resolve local. Right? And then, yeah. At the end, after you've finished, I guess finished with the block it was defined in, you'd want to say, take a look at all the variables that had the resolve local called on them and say, did this get resolved? I guess that's... Is there a better way to do that? No, I can't think of a good way to do that off the cuff. I have to think about that one, and maybe tomorrow we can dive into that. Our resolver calculates which environment the variable is found in, but it's still looked up by name in that map. A more efficient environment representation would to store local variables in an array and look them up by index. Really? Why? Extend the resolver to associate a unique index for each local variable declared in scope. When resolving a variable access, look up both the scope the variable is in and the index and store that. In the interpreter, use that to quickly access a variable by its index instead of using map. So in the interpreter then we could say what the index is of the variable inside the interpreter. So the resolver would create a map from the variable name to the index at which the variable is stored. And then instead of having to look up the variable in a hash map every time, we just grab the index that it's stored at in some array. And then we have it right there. That's an interesting concept. Huh. All right, you'd have to modify the variable. You'd have to extend the variable definition to say what index it is. All right, if I look at expr here and look at variable expr, right now all we save is the token, but we could extend this. I'm not going to do it, right? But extend this to index, which is option usize. And then when we do the resolve, we store the index. The resolver itself would have to create the index and then pass that into the interpreter and say, okay, for this variable, use this index. If we look at this code here, though, this is just a hash map right now. It does store the usize, but that's the size, that's how many scopes to look back for that variable. It would have to include, or maybe it would be a tuple, right? It would be how many scopes to look back and then the index in that scope. I guess that's the way to do it. I'm not going to do it right now, but okay, these are a couple of things maybe I can spend some time thinking about, and maybe that would be a good Thursday or Friday stream where we just riff on these challenges. All right, enough blathering. Let's move on to classes. Get status. Mirror clean. Okay. Classes is chapter 12. We're 11 chapters in, and the interpreter sitting on your machine is nearly a complete scripting language. It could use a couple of built-in data structures like lists and maps, and it certainly needs a core library for file I/O, user input, etc. But the language itself is sufficient. We've got a little procedural language in the same vein as BASIC, Tickle, Scheme, minus macros, and early versions of Python and Lua. If this were the 80s, we'd stop here, but today many popular languages support object-oriented programming. Adding that to locks will give users a familiar set of tools for writing larger programs. Even if you personally don't like OOP, this chapter and the next will help you understand how others design and build object systems. If you really hate classes, though, you can skip these two chapters. They're fairly isolated from the rest of the book. Personally, I find it's good to learn more about the things I dislike. Things look simple at a distance, but as I get closer, details emerge and I gain more nuanced perspective. OOP and classes. There are three broad paths to object-oriented programming: classes, prototypes, and multi-methods. Classes came first and the most popular style. With the rise of JavaScript and to a lesser extent Lua, prototypes are more widely known than they used to be. I'll talk more about those later. For locks, we're taking the classic approach. Multi-methods are the approach you're least likely to be familiar with. I'd love to talk more about them. I designed a hobby language around them once, and they are super rad. But there are only so many pages I can fit in. If you'd like to learn more, take a look at CLS, the Object System in Common Lisp, Dylan, Julia, or Raku. Since you've written about 1,000 lines of Java code with me already, I'm assuming you don't need a detailed introduction to object orientation. The main goal is to bundle data with the code that acts on it. Users do that by declaring a class that exposes a constructor to create and initialize new instances of the class, provides a way to store and access fields on instances, defines a set of methods shared by all instances of the class that operate on each instance's state, and that's about as minimal as it gets. Most object-oriented languages, all the way back to Simula, also do inheritance to reuse behavior across classes. We'll add that in the next chapter. Even kicking that out, we still have a lot to get through. This is a big chapter and everything doesn't quite come together until we have all of the above pieces, so gather your stamina. Like we do, we're going to start with syntax. Class statement introduces a new name, so it lives in the declaration grammar rule. The new class decl rule relies on the function rule we defined earlier. To refresh your memory, this is the function rule. So a class decl is an identifier followed by the word class, followed by an identifier, followed by open brace, followed by 0 or more functions, followed by a close brace. In plain English, a class declaration is the class keyword, followed by class name, then curly brace body. Inside that body is a list of method declarations. Unlike function declarations, methods don't have a leading fun keyword. Each method is a name, parameter list, and body. Here's an example. Not that I'm trying to say methods aren't fun or anything. All right, so we have class breakfast, cook, print eggs are frying, serve who, print enjoy your breakfast who. Like most dynamically typed languages, fields are not explicitly listed in the class declaration. Instances are loose bags of data, and you can freely add fields to them as you see fit using normal imperative code. Over in our AST generator, the class decl grammar rule gets its own statement node. All right, let's get started. So we have block, so we can add class. And this is going to contain a token of name, a vec of a vec of functions. And I think it's going to be like this, where we have a RC vec RC statement, right? Oh no, function. Yeah, right. And that's going to be the methods. And those are all going to end up being function statements. It stores the class's name and the methods inside its body. Methods are represented by the existing statement function class that we use for function declaration. That gives us all the bits of state we need for method: name, parameter list, and body. A class can appear anywhere a named declaration is allowed, triggered by the leading class keyword. Okay, let's hop over to the parser. In declaration, so here's where we matched fun. So we're going to make this an else. Change this to if self is match. Token type class. Return. Oh, we can just say self class declaration. Like that. Okay, this calls out to this. So we have a private, private function, class declaration, not self, result, RC statement, or a LOX result. Okay, so let name is equal to self consume. Question mark, and then we're going to consume token type left brace. And then we're going to create an array here. Let mot methods equals vec new. token type right brace, and not self is at end. Methods dot push self function method. All right, and then we consume. Oh, I forgot the question mark up there. I'm gonna hit F1 again. Consume. After class body. Question mark. And then return. And these things are getting very complicated. Okay. RC new. Statement class. RC new. I'm just following this thing here. And it's going to be a class statement, which is going to take a token, or name, and methods. We don't need the return statement. Okay. Oh, did I miss a... I missed a closed bracket here. Yeah. Okay. It should be a comma. What's this? Oh, yeah, we haven't written visit class statement for the interpreter or the resolver. So let's ignore those for now and then take a look here. Expected struct RC. Oh. Like that. No, it still didn't like that. Found enum result. What? Expected struct. Found struct vector result. Oh! This has to get a question mark. There we go. Yeah, okay, there we go. Very good. There's more meat to this than most of the other parsing methods, but it roughly follows the grammar. We've already consumed the class keyword, so we look for the expected class name next. Right, followed by the opening curly brace. Once inside the body, we keep parsing method declarations until we hit the closing brace. Each method declaration is parsed by a call to function. Okay. Like we do in any open-ended loop in the parser, we also check for hitting the end of the file. This won't happen in the correct code since the class should have a closing brace at the end, but ensures the parser doesn't get stuck in an infinite loop if the user has a syntax error and forgets to correctly end the class body. We wrap the name and list of the methods in a statement class node and we're done. Previously, we would jump straight into the interpreter, but now we need to plumb the node through the resolver first. All right, so let's work on the resolver. So the resolver for visit class statement looks pretty straightforward, right? Takes a self. This is empty. And then it'll take the statement. Like that, and it's just self-declare. And define. And then it's okay. We aren't going to worry about resolving the methods themselves yet, so for now all we need to do is declare the class using its name. It's not common to declare a class as a local variable, but LOX permits it, so we need to handle it correctly. Now we interpret the class declaration. So this should be good, right? We should be down to one error just in the interpreter. All right, so now we have visit class statement here. Okay, environment define LOX class is new LOX class. Oh, that's something new. And then environment assign the name to the class. Oh, so this has to be an object type. I see. And then return null. Yeah, so whenever we do this environment assign business, that means that we're making a new object type. So before we can even do this, I'm just going to stub this out because we're going to have to modify object now. Right? We have function callable. We're going to have to create a class, locks class, I guess, and create a locks class type. I see that down here. So let's create a file, locks class, and we'll just put this in here, pub struct. Oops, forgot the name, locks class, and we just say name is a string, and that's all there is to it, right? We construct, this is a constructor and this is the printer, so I guess I don't care about that. Oh wait, I do need to add it here though, right? Oops, just put it, object class C, right bang, F, class C dot name. Oh, you know what? We can just use we can write toString, right? And we can add that to here. Rust has a toString trait, right? Rust toString trait. Let's use that. Standard string. Right? Well, this won't work because I didn't put it in main, right? Here, do that. Mod locks class. Nope, I gotta add it here. Use create locks class. 4 errors. Oh, okay, and then I guess we need to make this derive, debug, clone, and partial EQ. All right, so we have 3 warnings, right? Because we're not using it. That's fine. All right, let's go and use it now. Oops, that's the roguelike. Here we go. We were in the interpreter. And we were doing this. Okay, so we say self environment. Borrow. I'm following this line down here. Borrow mut. Define. Statement name as string. And null, which is object null. Then we say let class equals new, not new, locks class, object class, locks class of, oh, it's not pub, so I'm gonna have to just say, I'll say locks class new statement name as string. Otherwise I'd have to make that thing pub, and I don't want to do that. So I need to fix that in a second. And then self environment borrow mut assign statement name to class. Okay, so that's that. Let me fix locks class now, which of course is not my Git files. just to add a new. I guess we could do this, right? And then just say logs class. Oh, right. I want to use self, and then self name. Can I do that, or do I have to name clone it? I do need to name.clone it. And it doesn't like this. Wow, I'm getting bad here. Okay, so now we're down to 2 warnings, and that's just that. Oh, there's a result that could happen here. Okay, that's good to know. On the assign, what do we do in other assigns? All right, we just return it back. Okay, good enough. Good. All right. This looks similar to how we execute function declarations. We declare the class's name in the current environment, then we turn the class syntax node into a logs class, the runtime representation of a class. We circle back and store the class object in the variable we previously declared. That two-stage variable binding process allows references to the class inside its own methods. We will refine it throughout this chapter, but the first draft of logs class is like this. Okay, literally a wrapper around a name. We don't even store the methods yet. Not super useful, but it does have a two-string method, so we can write a trivial script and test that class objects are actually being parsed and executed. Ooh, can we do this? Devonshire cream. We have a whole bunch of logs functions here, so let's put that in there. Cargo run that. Oh, look at that! It printed the class name. I changed the output. This just has to return string, but I put this here in our object output printer, so that's working. Nice. All right, now we have to create instances. We have classes, but they don't do anything yet. Logs doesn't have static methods that you can call right on the class itself. So without actual instances, classes are useless. Thus, instances are the next step. While some syntax and semantics are fairly standard across OOP languages, the way you create new instances isn't. Ruby, following Smalltalk, creates instances by calling a method on the class object itself, a recursively graceful approach. Some, like C++ and Java, have a new keyword dedicated to birthing a new object. Python has you call the class itself like a function. JavaScript, ever weird, sort of does both. In Smalltalk, even classes are created by calling methods on an existing object, usually the desired superclass. It's sort of a turtles all the way down thing. It ultimately bottoms out on a few magical classes like object and metaclass that the runtime conjures into being ex nihilo. Okay. I took a minimal approach with locks. We already have class objects and we already have function calls, so we'll use the call expressions on class objects to create new instances. It's as if a class is a factory function that generates instances of itself. This feels elegant to me and also spares us the need to introduce syntax like new. Therefore, we can skip past the front end straight into the runtime. Right now, if you try this, you get a runtime error. Bagel. And we say bagel. Can only call functions and classes. You get a runtime error. Visit call expert checks to see if the called object implements locks callable and reports an error since locks class doesn't. Not yet, that is. All right, so now we need to implement locks callable Oh, how do we handle this? Because I don't check to see that it's locks callable. I just check to see if it's a func, right? Right? Yeah, I just say, is it a function? And then we can call it. And if you can't, then you can only call function classes. So that's different to, is it a locks callable? What's a good way to do this? Because now we're going to have to say, right, you know, if we have this code here, then we have to say else if let object class is callee, then we repeat all of this code, right? Check the argument length and then call the class function. And that's if class implements locks callable. But we should be able to put it in a generic type, right? Is that possible? Let callable is equal to match callee object function. I don't know, you can't do this with traits, right? It locks callable. I don't think you can do this. I'm going to try it though and see what blows up. Yeah, trait objects must include the din. Oh, okay. Can I do that? Cast unsigned types. Call callable as din locks callable. Help consider using a box or reference as appropriate. No. An as expression can only be used to convert between primitive types or to coerce to a specific trait. Isn't that what I'm doing? Aren't I trying to coerce it to a specific trait? Rust coerce to trait. Following coercions are called unsized coercions since they relate to converting sized types to unsized types and are permitted in a few cases where other coercions are not, as described above. They can still happen anywhere else a coercion can occur. Two traits, unsized and coerce unsized, are used to assist in this process and expose it for library use. The following coercions are built in, and if T can be coerced to U with one of them, then an implementation of unsized U for T will be provided. T to din U, which is what I'm trying to do, when T implements U plus size and U is object safe. Oh. Is that all I need to do? Is change that to that? right? Because right now, if I take that away, then it says callable as din callable. Oops. Right, it says help consider using a box or reference as appropriate. But it sounds like if T implements use plus sized, so I would just have to implement sized for function. How do you do that though? Can I just say derive sized? No. It's only a trait without a derived macro. Sized, something like that? No, don't do it like that. How do you add sized to a Rust struct implement sized? All type parameters influence the bound of size. It can be used to remove this bound if it's not appropriate. Oh, I see. So does locks callable have to implement sized? Where is locks callable? Here. So this is where I have to put colon size. Oh, and now of course that blows everything up. For a trait to be object safe, it needs to at least allow building a V table to allow the call to be resolvable dynamically from a permission visit. Okay, so if you make the locks callable, this should be in its own file here, this trait. If I make this sized, then I can't do this. So is there something I can do to callable that'll allow that to work? Rust. Trait sized. Let's see. Object safe. Try an enum, yeah. Try type erasure. Isn't that what I was trying to do? I'm not sure what this is trying to do here. Change the trait. What makes a trait object safe? A trait can't have any take self by value as a receiver without a sized. Include any associated functions. Reference the self type outside the receiver's position. Include any generic parameters. So, which one am I violating? I'm not taking a self by value anywhere. I don't have any associated functions. I'm not referencing the self type outside of the receiver position. And I'm not including any generic parameters. But adding this size makes it so that callable locks callable, which is this, cannot be made into an object. No size trait. All right, so that means I can't. I don't understand what I need to do here. It should be possible, right, to convert this into the locks callable that it is, and then just call things once. But I don't know how to do that in Rust. That's something I'll have to do some investigation on. So meanwhile, I guess we just have to do it the hard way, right? We just repeat the code, which is unfortunate. Else, if let object class, let's call e if arguments, and we just copy this and change function to class. If class just implements locks callable directly, we don't need this actual func in the way, right? We can just say class arity and class call. Maybe that's what the problem was. Source locks class. We can just say impl locks callable for locks class. I can just stub them out for now. Although this looks pretty straightforward. Oh, we have to create a new locks instance type. Fn call. So what is the we need these three guys. Okay. And it's just going to return object nil for now. Okay, object nil. That's easy. This returns 0. And this, this has toString. We don't want to re-implement because I just did that toString here. We don't want double toStrings. Do I need to take this out of here then and do it smarter? Yeah. For now, let's just say this self name clone, but I need to clean this up. I think it's smarter to implement this trait than stick it in here as an additional method. Actually, let me just comment this out so that reminds me that I need to do that. Oh, we don't have object. Use create object. And locks callable. An interpreter, and what else do we need? Results, use, create, interpreter, and use create error, right? Okay, 3 warnings, and they are interpreters not used and arguments are not used. Okay, easy to fix. All right. We can't create instances now yet, but we can at least cargo run this, and we should get object nil back. Var b equals bagel. Does it get called? Something happened. Print b. It printed nil. And let's just verify that really quickly here. Locks class. If instead of returning nil, I return a number. That's what we should get back. Oops. Class bagel bar b equals, I can just say print bagel. Yeah, okay, so that's calling that function. What we want to actually do is return an instance, which is going to be yet another object type. Okay, so now we have to create locks instance. Let's get status. Add source before we go any further. Git commit. Starting work on object instantiation. Okay, so now we have to create a new struct called locks instance, and we're just going to cheat down here and go down. Oh, this is going to take a class and hash map and a map. Why? Is going to take a class, which is going to be a locks class. Actually, what it should be is a reference to a lock. We don't want to put the whole class in here, right? We want to put a reference to the locks class in here, which means that we need to, what's in our object? Yeah, we should be storing references to classes in here then, right? Because we don't want to RC new. Every time we create an instance, we don't want to create a new reference counted class, right? We want to just have one class that we reference count back to. Custodian, thank you for the follow. So that means that this needs to change to RC, and we'll just create a new, when we create a new class, we just have to create a new reference counted thing for it, and that's going to change our interpreter, right? Use standard RC C, and then go back to the interpreter and say RC new. There. Okay, so now in our instance, when we create a new class, locks class, the instance instead is going to say, ooh, how are we going to do that? If we call it, we definitely want to call it with the interpreter and the arguments, and it has to have the same function signature. But how are we going to get the, I have to think about this. How are we going to get the reference to the class itself in this call? Because that's what we want to create a new, unless we put that in the class too, right? Does it have a reference to itself? MyRef. RC locks class. That would be insane, right? And then you stick that in here, you'd have to pass in, but you're creating a new one. How are you going to create a let's try it and see how far we can get with it. Oops, I want to get rid of that and then change this back to, back to this, and then locks class. We want to have this, and then we'll say new and say pub fun set. self. This is very awkward. There's got to be a better way to do this, right? And then say self.myref equals myref. And then we have to put this back, use standard RC. Oh, this is, yeah, I can say none here. Okay. All right, so then here, instead of that, we do this. First we want to actually create the locks class. Let my class is equal to this guy, right? And then say my class setref rc new my class. Really? And then this is my class. Oh, set self. Yeah, I prefer set ref though. Let's change it to set ref. And it doesn't like that. Oh, yeah, because we're moving it. Yeah, so you can't even do that. You can't have a thing referenced to itself. Oh, how are we going to solve this problem? All right, let's undo all that and get it back to the working. This is the working version, right? Yeah. So object has a locks class. Is there something else we could do? That can, we should be able to get the reference to the object and still get the class. Okay, so the problem is that when we call locks class, right, like this line here, right, that's the syntax we're using for creating a new version of a new instance of the class object. So we want to be able to just say RC clone the class for the instance, right? This, well, I want in instance, I want to be able to do RC clone. Here's the code I want. Source locks instance, right? So impl locks instance, pub fun new, and I want to be able to pass in class, which is going to be RC locks class, and that's going to return a self. And I just want to say locks or self class is equal to, sorry, colon RC clone class. Right, that's what I want to be able to do, because I don't want to have duplicate locks classes everywhere. And when I call new, I don't want to have a brand new RC each time. And oh, I was going to say I don't know why that built, but I know why it didn't. It built. I know why it built, because I didn't input it in main. Hang on. RC. Oops, I got that backwards. Like that, and then source main. Let's add it here. Mod locks instance. locks class doesn't exist. Use create. Expected reference found struct RC. Isn't that what we want? Oh. Okay. Yeah. So this is what I want to be able to do. And in locks class, in call, I want to be able to say, okay, return a object. Sorry. Okay. Object. Instance of locks instance new something, and I want to pass in that RC. So that's where I want to go. And I don't want to say RC. I could say RC new self, right? But that would mean that every time we created an instance of the class, it would create a brand new RC that we would just clone and shove in here, and then what's the point of that, right? I want to have a single RC for each class, and somehow in here do just RC clone of whatever that is. And I was trying to do it with this myref business, but you can't do that. So I'm going to take that out. Oh, locks instance doesn't exist. I'm going to have to change that back to a new. Oops. From clone to new. Oh, and right, object doesn't have it yet. Okay. And then for instance, we're going to have to add something here. And it'll be i.class toString. And of course, class is not pub, so that's going to blow up by itself. Oh, and it doesn't know. Oh, yeah, so I can't even do this. I'm saying unknown field for a locks instance. That's right there. It's just not pub. All right. So this we can't even do it this way. This can't be formatted using that. Okay, I can fix that. Debug, clone, and partial EQ, right? Down to 2 errors. Oh, I did the wrong thing there. What did I do? Object. It should be an instance. There. Okay, so this is the issue I'm trying to solve, is how can I create a new locks class instance from source object. Right. So if I make this an RC, I guess what we could do is cheat in a big way. Because it doesn't have to be callable. It doesn't have to be callable. I mean, that's the way they do it here, is just it just makes things simple, but we can hack around it. So now class is an RC. We don't have to say call self arguments. We can say instantiate. We can create an instantiation function here. Self, which is the interpreter, arguments, which are the arguments for the instantiation, and then we can pass in the ref count, right? And then this just becomes an error. Oh, we need a token for runtime error. Right? Yeah, we need a token, which we don't have at this stage. I guess we can just do system error, because this is a tried to call a class. Right, so we'll just do that. And then we're going to have to write this instantiate. Oh yeah, RC new. And now instantiate needs to be written, source logs class. Pub fun instantiate, which is going to take these same arguments here. Plus, yeah, plus a RC, a class, RC logs class. It's going to return a result of object or logs result. And then, oh, I forgot the arrow. So then we want to call, we want to instantiate, we want to create a logs instance of this class. So what we do here, source logs instance, we call new. Okay. Object instance logs instance new class. Is that it? Oh, I put the arrow up there. Huh. No, and this isn't going to work because we're calling something and creating a thing on it. All right. I guess what I'm going to do is I'm going to go off and do some research and call this a stream, because this is not getting me anywhere. I'm going to have to figure out the right way to go about doing this. I thought I could get away with it by cheating my way around it, but Rust is not letting me cheat, quite rightly too. So I'm going to go look at this a little bit off stream, and then we're going to come back to this tomorrow, where we can and get this resolved. So once again, I'm leaving a stream partway through. My Twitch search broke. What happened to my Twitch search? Yeah, it's panicking. Invalid response. I wonder if Twitch changed their API. Probably. That's probably what happened. All right. I guess I can't can't look there, but what I can do is refresh and see if there's anybody we can raid. I guess Jackie. I don't know what she's doing these days though. All right, you know what? I'll just leave it there. We'll call it a stream. Tomorrow we'll take a look at, or we'll solve this class instantiation problem, and then start looking at properties on instances. So git status. I'm just going to commit these changes for now, so I have them. Git add source. Git commit. Broken code creating instances of classes. All right, and we'll leave it there, and then maybe I'll just I'll do an git amend tomorrow when we have everything working. All right, that's a shame, but thanks for hanging out with me, everyone, and I hope you have a great rest of your Monday, or if you're on Tuesday already because you're around the world, have a great Tuesday, and I will see you tomorrow the same time for working on crafting interpreters. All right, take care, everyone.